Formation Microimager is a special tool designed to investigate the strata by using a set of microprobe devices. Let's look how it's gonna work. The tool is designed like that. It got a few legs shown here. On this example, we're gonna have 6 legs. 1, 2, 3, 4, 5, 6. On each leg, we have 16 pairs of the electrodes. So we can see it. 1 pair, the second one, the third one, the fourth one, and so on. Each pair of the electrode records its own resistivity log, micro-resistivity log. So finally, we're gonna have 16 micro-resistivity logs recorded by each of these legs. So totally, from the tool, we're getting 96 resistivity logs. How we can plot these logs? How we can plot this information? We are taking these 2 electrodes. They are recording a single electrical resistivity log. We are taking these 2 electrodes and place here one tiny line. The shape of the line is not changing, but the color is changing. Once we get the dark color, it shows us the high resistivity. Once we get the light color, it gets low resistivity. Then we are taking the second pair. And this second pair gives us another log, which we are placing right nearby to the first one. Then we are taking the third pair of the electrode and place the third line right nearby to the second one, and so on. Once we finish with this one leg, we are obtaining this thick line, which is giving us the information about the resistivity in this interval. Then we are taking all of these 6 legs. We are taking 1, 2, 3, 4, 5, 6 legs, and we are getting this picture. Finally, we are getting this figure that is called the image. But how to read this image and what to do with the result? Let's examine how this tool is working. Imagine that my arms are the logging tool, the formation microimager. We are pushing that into the formation, then we open these legs and record the information. Finally, we are open that recording, and that's what we get on this figure. So we are plotting the internal surface of the well. Why do we need to have the resistivity of the internal surface of the well? Let's look at that example. Imagine that that is the simple model of the well geometry. Just look at it. And you see that our well is crossed by a certain inclined, in this case, we just cut this well by this inclined surface. Now let's open this well model to see how this cutting looks like once we open the well. You see the geometry. We have a kind of a sinusoidal shape of this crossing. That simply means that once a kind of a thing crossing our well with an angle, not perpendicularly, once we open the well, it's gonna looks as the sinusoidal shape anomaly. Now let's look at the slide. You see here we have this kind of sinusoidal shape anomaly. Because of this sinusoidal shape anomaly, we can see that something is crossing our well with a certain angle. And in this case, this something is the fracture. So formation microimager allows us to find the fractures in the formation. But not only find the fractures, but also estimate its geometry. The main objectives of the formation microimager are thin layer detection, determination of the presence of the fractures, and determination of the angle of inclination of layers and fractures. Limitations. It is not applicable in a cased well. It's not applicable in non-conductive drilling mud. Just like with the micro-resistivity, the significant change in the diameter of the well bore gonna change the readings. And the mud with the resistivity less than 0.05 ohm meters is another limitation for the application of this method.